Hello everyone, my name is Stephanie Woodruff, and today I'll be demonstrating an interesting experiment involving fireproof balloons and explaining the thermodynamic and thermochemical principles behind it. The aim of this experiment is to demonstrate how heat transfer differs between gases and liquids by using balloons filled with air and water, and to explore the thermodynamic and thermochemical concepts that explain these observations. So let's get started with our materials. We're going to need 2 balloons, water, and a source of fire, like a candle or a lighter. And please be sure to be safe if you decide to do this experiment at home. Be sure you're in a controlled environment. I hypothesize that the balloon filled with air will pop when exposed to the fire, while the balloon filled with the water will not. And this can be explained by the different heat capacities and heat transfer properties of gases and liquids. So to get started, I went ahead and filled up my balloons in advance. I went ahead and blew this up. This is just air. And then I filled this up about 1/4 of the way with water and then blew it the rest of the way up with air. Now, I went ahead and lit a candle in advance. And the first thing we're going to do is get our balloon with just air and hold it over our heat source. And let's observe what happens. And as I expected, it popped. It also blew out our candle, which now we're going to need to relight. Now we're going to try this with our water-filled balloon. And we're going to hold this over our heat source, and you can see the flame is completely touching the balloon, and it is not popping. Wow, see that? So, let's talk about some of our observations that we've just seen here. As expected, the balloon with the air pops almost instantly when the flame touches it. The water-filled balloon, on the other hand, it actually was able to stay intact and is still okay. So we noticed that the balloon doesn't pop, even though it is in direct contact with the flame. So what's the explanation for this? Thermodynamics and heat transfer. Thermodynamics is the study of heat and energy transfer. And in this experiment, we're observing the first law of thermodynamics, which states that energy cannot be created nor destroyed, only transferred or transformed. When heat is applied to the air-filled balloon, the thermal energy is transferred quickly to the air inside because gases have a lower heat capacity and conduct less heat and is less efficient than liquids. This rapid transfer of energy increases the internal energy of the air, causing it to expand and eventually pop, which we saw that was almost instantaneous. Specific heat capacity. Water has a high specific heat capacity, which is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Water's specific heat capacity is 4.8 joules per gram per degree Celsius, much higher than that of air, which is around 1 joule per gram per degree Celsius. This means that water can absorb a large amount of heat without a significant increase in temperature. When the water-filled balloon is exposed to the flame, the water absorbs the heat, preventing the balloon from reaching a temperature high enough to weaken and pop the balloon. So heat transfer occurs through conduction, convection, and radiation. And in this experiment, conduction is the primary mode of heat transfer. Conduction in gases like air is less efficient because the molecules are further apart compared to liquids where molecules are closely packed and can transfer heat more effectively. Another important concept is latent heat, the heat required to change the state of a substance without changing its temperature. If the water in the balloon were to heat up significantly, it could absorb enough energy by undergoing a phase change from liquid to vapor, further protecting the balloon from popping. So in summary, this experiment demonstrates the principles of thermodynamics and thermochemistry, showing how different substances respond to heat. The air-filled balloon pops because of the rapid heat transfer and low heat capacity of air, while the water-filled balloon doesn't pop due to water's high specific heat capacity and efficient heat absorption. Thank you for watching my experiment. I hope you enjoyed it. Until next time.